Hello students, welcome to Eshwari Thaniksha channel. Students, in this video I'll tell you what you have to learn in this concept, that is dipole moment, and how the question will appear in NEET examination. So first let us analyze the questions which has already appeared in NEET examination. So first question from NEET 2024 paper. Identify the correct answer. Three canonical forms can be drawn for carbonate ion. Three resonance structures can be drawn for ozone. So these 2 points are from resonance. BF3 has non-zero dipole moment and dipole moment of NF3 is greater than that of ammonia. So these 2 points are from dipole moment. So you can see in one question, two concepts are given. So these two are from resonance and these two are from dipole moment. So second question, this is from NEET 2020 question paper. Which of the following has zero dipole momentum? So molecules will be given. You have to identify which is having zero dipole moment. So from this question, it is very clear that no need to memorize the values of dipole moment. So let us see NCERT textbook. So this is NCERT textbook. So let us see in NCERT textbook. See this table. Table 4.5, dipole moment of selected molecules. So here dipole moment values are given 1.78, 1.07. So all these values no need to memorize. Don't memorize because they will not ask what is the dipole moment value of hydrogen fluoride. So 1.78. So they will not ask question like this. So don't memorize the values. So questions how it will appear is molecules will be given. You have to compare and see which is having more dipole moment and which is having lesser dipole moment and which will be having zero dipole moment. So that is what is very important. So let us learn the concept, and also we will see in NCERT textbook the points which you have to note down for your NEET examination. So dipole moment, first we will see what is dipole moment. So students, first let us take two examples. Hydrogen molecule, hydrogen fluoride. So the bond which is formed between hydrogen molecule, so this is called as covalent bond. What is covalent bond? A bond which is formed by sharing of electron. So hydrogen will give one electron and this hydrogen will give one electron. So they will share this electron pair. So that is called as covalent bond. And coming to hydrogen fluoride, even this is a covalent bond. And here, since both are hydrogen atom, electronegativity will be same. So there is no charge separation between them. Whereas here hydrogen and fluorine, if you compare, so fluorine is more electronegative when compared to that of hydrogen. So as a result, these electrons will be attracted more towards fluorine. As a result, fluorine will be getting partial negative sign and hydrogen will be getting partial positive sign. So can you see there is charge separation now? So this kind of charge separation, if it is present, then it is called as polar covalent bond. And here this is non-polar covalent bond. So now let us see the definition for dipole moment. So dipole moment is represented by the symbol mu. So mu is equal to the product of charge into distance between positive ion and negative ion center. So here you can see this is positive ion and this is the negative ion. The center of this positive ion and negative ion distance, if you take, that is called as D. So the product of charge into distance is called as dipole moment and it has a unit. So what is the unit? So unit is called as D by. So you will be representing by capital D. So this is called as dipole moment. Diatomic molecule. So diatomic molecule is of two types: homonuclear diatomic and heteronuclear diatomic. Homo meaning is same kind of atoms will be present. Hetero meaning is different kind of atoms will be present. Example H2 and F2. So here you can see same type of atom, hydrogen and hydrogen. Here you can see fluorine and fluorine. If same type of atoms are present, it is called as homonuclear diatomic molecule. In hetero you can see different hydrogen and fluorine. Hydrogen and chlorine is present. So here you can see homonuclear diatomic molecule, they are non-polar in nature. Non-polar covalent bond will be present. If it is non-polar in nature, then their dipole moment will be equal to 0. So remember that for a non-polar molecule, dipole moment will be equal to 0. And these are polar covalent bond. So for a polar molecule, the dipole moment is not equal to 0. So this much you have to remember. So coming to heteronuclear diatomic molecule. For example, these 4 molecules are given. So now you have to find out which is having more dipole moment and which is having less dipole moment. For this I'll teach you a trick. So what is the trick you are going to use this? So using one trick, again we can solve many types of questions. So difference in electronegativity if it is more. So remember, difference in electronegativity if it is more, then dipole moment also will increase. If dipole moment increases, percentage ionic character also will increase. Ionic character also will increase. If percentage ionic character increases, then their acidic character will decrease. So this is the trick. So using one trick, you will be able to solve many types of questions. So here, so how you will find dipole moment? If you know their electronegativity difference, you can find their dipole moment. So if you know dipole moment, you can say whether their percentage ionic character is increasing or decreasing, and also you can find their acidic character. So now the question is, out of this 4 molecule, which is more acidic in nature and which is less acidic in nature? Can you tell me which is strong acid and which is weak acid? So by using this trick, we are going to find. First we will find dipole moment and we will find their acidic character. So first let us find their dipole moment. So here hydrogen has electronegativity value 2.0 and fluorine will be having 4.0. And again here hydrogen 2.0, chlorine will be having 3.0. Hydrogen 2.0 and bromine will be having electronegativity difference 2.8. And for hydrogen 2.0 and iodine it is 2.6. So where the electronegativity difference is more? So see here 4 minus 2 is 2. So the difference is 2. 3 minus 2 is 1. Difference is 1. And here 2.8 minus 2 is 0.8. And here 2.6 minus 2 is 0.6. Where the electronegativity difference is more? Here it is more. So we found the electronegativity difference is more here in hydrogen fluoride. So electronegativity difference is more when compared to Hi. So here electronegativity difference is less. So next. So where the dipole moment is more? So here the dipole moment will be more and here the dipole moment will be less. So compared to this, we are comparing here and here. So dipole moment will be less. And then acidic character we will see. So what is the relationship here? So you can see the relation is when dipole moment increases, acidic character will decrease. So here you can see dipole moment is increasing here. Therefore, their acidic character will decrease. Acidic character will decrease. And here acidic character will increase. Acidic character will increase. So now can you say which is more acidic in nature? So here Hi is having more acidic character when compared to HF. What is the reason? Because of dipole moment. Dipole moment is less. Therefore, acidic character will be more. So students, with one trick, you can tell their electronegativity difference, their dipole moment, their ionic character, and also their acidic strength also we can find if you are using this trick. Next we will go for polyatomic molecules. So for a polyatomic molecule, so dipole moment can be 0 or it won't be 0. So first we are taking example where dipole moment is equal to 0. Polyatomic meaning is more than 2 atoms will be present. So we have taken example where dipole moment is equal to 0. First we will take first example. So students, for polyatomic molecule, dipole moment depends on their geometry. So you should know their geometry, then we can easily find out their dipole moment. So first we will see first molecule BeF2. So what is their geometry? I have already taught you the trick in the last class. So how to find their geometry. If you have not watched, you can watch that video. So here we will see how to find their geometry. So for BeF2, for Be, how many valence electron will be present? So here you can see I have written the valence electrons for some of the atoms. So lithium and sodium will be having 1 valence electron. Beryllium, magnesium, calcium will be having 2 valence electron. Boron and aluminium will be having 3 valence electron. So you can remember this table. So for beryllium, Be, the number of valence electron is 2. So I'll write there are 2 valence electron. So these 2 electrons, out of this 2 electron, 1 electron is used for bonding with fluorine and another is used to bond with fluorine. So can you see here how many fluorine atoms are there? 2. So one will form bond using 1 electron and another fluorine will form bond using another electron. So totally all the 2 electrons are used in bonding. So therefore lone pair of electron will be equal to 0. So we can write here. So A, how many bonded atoms are present? A is central atom. Here central atom is Be. So here bonded atom are 2. So we will be writing B2. And then lone pair of electron 0. So A, B2, L 0. So totally if you add, this is 2 plus 0. So 2 plus 0 is equal to 2. So if it is 2, then hybridization is SP. If it is sp hybridization, the structure will be linear. Geometry will be linear like this. So Be will be in the center and here one fluorine atom and here one fluorine atom will be present. So dipole moment will be exerted in the direction of more electronegative atom. So fluorine is more electronegative. Fluorine is more electronegative when compared to that of beryllium. So therefore you will be writing arrow like this in this direction and then line like this. Again this fluorine you will be writing like this and a arrow mark like this. So here they are in opposite direction. So their value will get cancelled. Since dipole moment depends on the direction, so here dipole moment will cancel each other. Therefore dipole moment will be equal to 0. So for the first molecule dipole moment is 0 because the structure is linear. We'll see for the second one. For the second one, central atom is A. How many bonded atoms are present? There are 3 bonded atoms. So this is the central atom and this is the bonded atom. 3 bonded atoms are present. So how many lone pair is present? So let us see how many lone pairs are present using the trick. So here for the beryllium, how many valence electrons are there? So see beryllium, boron will be having 3 valence electron. So you will be writing 3 valence electron. So out of this 3 valence electron, one will be used for bonding with fluorine, another with another fluorine and another with third fluorine. So because totally 3 fluorine atoms are present, so this 3 electrons will be used by 3 fluorine atom for bonding. Therefore there is no lone pair of electron present. So lone pair of electron is equal to 0. So add this 2, you will be getting 3 plus 0 is equal to 3. So if it is 3, the hybridization is sp2. So if it is sp2, the shape is trigonal planar. So it will be like this, trigonal planar. So boron will be here, fluorine will be here In this direction, second fluorine and third fluorine. So F, F and F. So now the dipole moment which is exerted by this fluorine. So always the arrow mark should be towards more electronegative atom. So you will be writing like this. And here you will be writing like this. Towards fluorine atom. So since it is a planar molecule. So since it is a planar molecule, meaning is the molecule is exhibiting symmetry. So if it is symmetry, then you can say that the dipole moment will be equal to 0. So one more trick to find out whether the dipole moment is equal to 0 or not is if the bond angle is same. So here the bond angle is 120. This bond angle is also 120. This bond angle is also equal to 120 degree. So if the bond angle is same, then also you can say that dipole moment is equal to 0. So we found that even for BF3, dipole moment is equal to 0. So we'll go for CH4. So carbon will be having valence electron 4. So all this 4 will be used by 4 hydrogen atom for bonding. So therefore you will be using central atom and then bonded atom is 4. Lone pair of electron is 0. So here add this to 4 plus 0 is 4. So if it is 4, hybridization is sp3. So if it is sp3, then the structure is tetrahedral. So carbon, one hydrogen here, hydrogen, hydrogen and hydrogen. So I said you that if the bond angle is same, then the dipole moment will be equal to 0. So here the bond angle is 109.5 degree. So everywhere you can see 109.5 degree. So bond angle is the same, 109.5 degree. So therefore you can say that CH4 is symmetrical and dipole moment is equal to 0. So next we will see CCl4. Again CCl4 same it is. So carbon will be having 4 valence electron and all the 4 valence electrons are used by 4 chlorine atom for bonding. So therefore lone pair of electron will be equal to 0. So you can write central atom, then bonded atom is 4, then lone pair is 0. So 4 plus 0 will be 4. If it is 4, hybridization is sp3. So if it is sp3, again you will get same type tetrahedral shape. So tetrahedral, the bond angle will be same. So this is symmetry. This molecule will show symmetry. So therefore dipole moment will be equal to 0. So next we will go for SF6. So in SF6, central atom is sulfur, we will write as A. Bonded atom is 6 are there. So now write valence electrons. How many valence electrons are there in sulfur? So just check how many valence electrons are there in sulfur. So you can see this is sulfur. Valence electrons are 6. So you will write 6 valence electrons are there and all the 6 valence electrons are used by fluorine. 6 fluorine atoms are there. So all the 6 will be used. Therefore lone pair of electron will be 0. So you will be writing A, B6, lone pair of electron is 0. So you add this to 6 plus 0 is equal to 6. So hybridization is sp3d2. So if hybridization is sp3d2, what is the geometry of the molecule? It is octahedral. So sulfur, fluorine, fluorine here, fluorine, one in the top and one in the bottom like this. So here the dipole moment which is exerted by this fluorine and this fluorine will get cancelled because they are in opposite direction. You can see they are in opposite direction, and the dipole moment which is exerted by this fluorine and this fluorine will be in this direction, and the dipole moment which is exerted by this fluorine and this fluorine will be in this direction. So again they will cancel each other. As a result, dipole moment will be equal to 0. So one more method is if the bond angle is equal. So here you can see all the bond angle will be equal to 90 degree. So just measure. You can see the bond angle will be 90 degree in octahedral structure. So therefore this molecule shows symmetry and the dipole moment will be equal to 0. So this is, remember this examples where dipole moment is equal to 0. So second type where dipole moment is not equal to 0. So we will see here why it is not equal to 0. So sulfur, how many valence electrons are there in sulfur? So just now we have seen, so sulfur has valence electron 6. So you will write 6 valence electrons are there. So out of this valence electron, so oxygen, you know that always it will form double bond. So with sulfur also it will be forming double bond. So one oxygen will form one double bond. So same way, so out of the 6 electron, so it forms 2 bond with oxygen and 2 bond with oxygen. So it is using 2 electrons. So 2 electrons here and 2 electrons here. So out of 6 electron, if 2 and 2 if you remove, that is 4 electrons if you remove, how many electrons will be remaining? 2 electrons will be remaining. So 2 electron meaning is 1 pair. So 1 lone pair will be present. So here the central atom is A, sulfur is the central atom, and then bonded atom is B2. How many lone pair of electrons are present? 1 lone pair of electron is present. So add this 2, you will get 2 plus 1 is equal to 3. So if it is 3, what should be the hybridization? Hybridization is sp2. So if sp2 is the hybridization, you will be representing like this: sulfur, oxygen, oxygen, and then 1 lone pair of electron. So now dipole moment, oxygen is more electronegative than sulfur. So you will be representing dipole moment in this direction like this, and then in this direction like this. Lone pair of electron, so always remember that dipole moment for lone pair of electron, it will be towards the lone pair. So it will be represented like this. So here dipole moment is not equal to 0 because you can see here these two are same kind of atom giving some dipole moment, whereas this is lone pair of electron. So the dipole moment which is given by this lone pair of electron will be different. So therefore they will not cancel each other. As a result, the dipole moment is not equal to 0. So remember, dipole moment is not equal to 0 if lone pair of electron is present in them. Is that clear? So we'll go for the second example. So second example is H2O water. So here the central atom is oxygen. How many lone pair of electron is present in oxygen? So oxygen, 6 lone pair of electron, 6 valence electron will be present. So valence electron 6. So out of this 6, 1 is used by hydrogen for bonding and 1 is used by hydrogen for bonding. So if 1 and 1 if you remove, so how many will be remaining? 6 minus 2 will be 4. So 4 electrons will be remaining, that is 2 pair. So 2 lone pair of electrons will be present in water. So you can represent as oxygen, hydrogen, hydrogen, and then 2 lone pair of electron, 1 and 1. So dipole moment, so always you know that the arrow should be towards more electronegative atom. So oxygen is more electronegative. Oxygen is more electronegative when compared to that of the hydrogen. So therefore arrow will be in this direction like this. So from hydrogen to oxygen like this. And lone pair always towards the lone pair. So it will be in this direction. In this direction. So since you can see that all are in the same direction, they will not cancel each other. So dipole moment is not cancelling each other. Therefore dipole moment will not be equal to 0 in water molecule. So next we will go for ammonia and NF3. So we will have to compare these two. So let us compare which is having more dipole moment and which is having lesser dipole moment. So first we will take ammonia. So N, there are 3 hydrogen atom and then 1 lone pair of electron is present. So same way in NF3, nitrogen, fluorine, 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 and 1 lone pair of electron will be present. So now which is more electronegative in nature? whether nitrogen is more electronegative or hydrogen is more electronegative. Nitrogen is more electronegative in nature. So therefore you can write the arrow like this towards nitrogen atom. So towards nitrogen. And to lone pair, you know that always arrow should be towards lone pair. So you will write like this. So here you can see all the arrows are in one direction. So they will not cancel each other. As a result, dipole moment is not equal to 0. In second molecule, we will see. So here fluorine is more electronegative when compared to that of nitrogen. So therefore, arrow should be in this direction. Arrow is in this direction towards fluorine, and lone pair always towards the lone pair. So here you can see 3 arrows are in one direction, whereas for the lone pair it is in the opposite direction. Therefore some of the dipole moment will cancel. As a result, the dipole moment here is less when compared to here. Here it will be more because all the arrows are in one direction. Here it is cancelling because they are in opposite direction. So if you compare these two, here it will be less and here the dipole moment will be more. And some more examples. So these are very important. So this question has already come in JEE. So where the dipole moment is more. So we will solve this question. So CHCl3, so carbon, 1 hydrogen and 3 chlorine atoms, Cl, Cl and Cl. And here carbon, hydrogen, hydrogen, hydrogen and then 1 chlorine. So students, pause this video, and if you know the answer which is showing more dipole moment, write in the comment section whether this molecule will have more dipole moment or this one. So pause the video. If you know the answer, write your answer in the comment section. So now let us see which is having more dipole moment. So here out of carbon and chlorine, so you know that chlorine is more electronegative. Arrow I'll write like this towards chlorine. So towards chlorine. So now between carbon and hydrogen, which is more electronegative in nature? So you know that carbon is more electronegative in nature. So therefore you will write arrow like this. But this is wrong. So here there is some exception. So wherever there is exception, make a note of it. So this has already appeared in JEE paper. So most of the students are going wrong here. So they will think that carbon is more electronegative, therefore arrow will be in this direction. So since all the arrows are in the same direction, dipole moment will be more. So here what is the differences? So here you can see chlorine is more electronegative in nature. Therefore, it is pulling the electron close to itself. As a result, what it is making is this carbon becomes electropositive in nature and hydrogen becomes electronegative because of presence of 3 chlorine atom. So as a result, the arrow mark will be in this direction because hydrogen is becoming more electronegative when compared to carbon, so which is now electropositive because of this chlorine atom. So now because of this opposite direction, dipole moment will reduce. All the 3 are in one direction and this is in the opposite direction, therefore dipole moment will reduce. We will see in the second molecule. So here carbon and hydrogen, if you compare, so here it will be towards carbon. So dipole moment will be exerted towards carbon. And then carbon and chlorine, if you compare, chlorine is more electronegative. So here you will write in this direction. So now you can see all are in the same direction. So if all are in the same direction, dipole moment will be more here. So therefore you can write dipole moment here it is more and here it is less. So therefore you will write like this. So here you will write dipole moment of this molecule CH3Cl will be more when compared to this. Next we will go for the next example. So we'll see in this example P. So here So there are two types of bonds here. So positions here, which is called as axial position and equatorial position. So this position is called as equatorial positions. All these positions are called as equatorial. 3 equatorial positions will be there and 2 axial position will be present. So here P will be the central atom. And here you can see chlorine is present and fluorine is present. Which is more electronegative in nature? Fluorine is more electronegative when compared to that of chlorine. So remember, more electronegative atom always should be present in the axial position. So here keep the fluorine atom in the axial position. Keep here axial position. And then remaining 3 chlorine atoms, it will be in the equatorial position. So 1 chlorine here, 1 chlorine here, and then 1 chlorine here. So now write their dipole moment. So here you know that fluorine is more electronegative than phosphorus. Therefore, so you will write dipole moment direction like this. Like this. And then for chlorine, towards chlorine like this. Towards chlorine and then towards chlorine like this. So here the dipole moment exerted by this fluorine and this fluorine, they are opposite in direction. Therefore, they will cancel each other. Same way, the dipole moment which is exerted by this chlorine also will cancel each other, because the bond angle between them is the same, which is 120 degree. I said when the bond angle between them is same, so you can write their dipole moment will be 0. So therefore, the dipole moment of this molecule will be equal to 0. So you will write here dipole moment will be equal to 0. So same way, can you try for this one? So can you write the answer in the comment section whether the dipole moment is equal to 0 or it will have some value. So take a minute and then try. So now we will write. So P, and then how many fluorine atoms are there? There are 3 fluorine atoms. So one will be in the axial position, second will be in the axial position, third one we have to place in the equatorial position, because only 2 axial positions are there. So one in the equatorial position we can place, and then two chlorine atoms here in the equatorial position. So now the dipole moment which is exerted by fluorine will cancel each other, but the dipole moment which is exerted in this triangle will not cancel each other. Why? Because different atoms are present. So they will be exerting different dipole moment. So they will not cancel each other. Whereas here you can see all are chlorine atoms. So they cancelled each other. But here it is different. So this is fluorine atom and here chlorine atoms are present. Therefore they will not cancel each other. Therefore they will have some dipole moment. So here you will write dipole moment is not equal to 0. So some dipole moment value will be given. So if you compare these two, dipole moment is 0 and here there is some value for this molecule. So now let us see the dipole moment in aromatic compounds. So first benzene. So benzene, you know that it is symmetric molecule. It shows symmetry. So remember that whenever there is symmetry, it is non-polar in nature. So if it is non-polar in nature, dipole moment will be equal to 0. So for benzene and CCl4, it is non-polar solvent. Therefore, their dipole moment will be equal to 0. So now we will go for this example. So in this 3 compounds, that is dichlorobenzene. So which is having more dipole moment and which is having lesser dipole moment, we are making comparison now. So let us find. So students, if only benzene is there, we can say the dipole moment is 0. But here chloro groups are attached. So see their position where they are attached. So this position is called as ortho position. And this is called as meta position. And this is called as para positions. Remember. So this is ortho. This is meta. Chlorine is attached at meta position. And here it is attached at para position. So now let us see their bond angle. You have to find their bond angle. How to find their bond angle is, so here this is the center. So here you are dividing the molecule 1, 2, 3, 4, 5, 6. So there are 6 carbon atoms. So you are dividing into 6. So 360 degree divided by 6. How much you will be getting? You will be getting 60 degree. So therefore, so if I write like this, so from here to here, so this will be 60 degree. So this much, so this will be 60 degree. So same way this will be 60 degree. This will be 60 degree. This will be 60 degree, 60 and 60. So totally it is 360 degree. So now here you can see, so from here to here it is 60 degree. So the bond angle is 60 degree between the two chlorine atoms. Chlorine atoms is attached to this carbon. So if you see their bond angle, so it is equal to 60 degree. So I'll write here. So here theta is equal to 60 degree. Their bond angle is 60 degree. So here you see second molecule, what is the bond angle? So here to here it is 60 and from here to here it is 120. So total from here to here, if you see, the bond angle is 120 degree. So theta is equal to 120 degree. So their bond angle is 120 degree. And here third. So here you can see chlorine atoms are exactly opposite to each other. So dipole moment will be in this direction and here dipole moment will be in this direction. They are opposite to each other. They are equal and opposite to each other. So therefore they will cancel each other. As a result, their dipole moment will be equal to 0. So here you will write dipole moment is equal to 0 here. But here in this two, dipole moment is not equal to 0. Dipole moment is not equal to 0. But where it is more? So where it is more and where it is less, we have to find. For that, remember this trick. So the trick what you are using here is, as theta increases, that is as bond angle increases, dipole moment will decrease. So this is the trick we are going to use. So as bond angle increases, dipole moment will decrease. So they are inversely proportional to each other. So see here, compare these two. So bond angle is more here. So as bond angle increases, dipole moment will be less. So therefore dipole moment here it is less and here it is more. So I'll write here. So dipole moment here it is more, or I can write like this. So dipole moment here it is more and here it is less, because theta here it is 60 degree and theta here is 120 degree. So here bond angle is more, therefore dipole moment is less. So and here in the third one, you know, it is equal to 0. So now let us solve the questions which we have seen in the beginning. See here. So can you see here what is given? So what is the dipole moment here? Chlorine atoms are exactly opposite to each other, therefore their dipole moment will cancel. So you can write dipole moment is equal to 0 here. And for water, there is lone pair of electron, 2 lone pair of electrons are present. Dipole moment is not equal to 0. So first option you can leave. So they are asking find where there is 0 dipole moment. So first option is wrong. Second, here you can see it is having some dipole moment. So this option also you can rule out. So here you can see again there is some dipole moment. So third option also we can rule out. So here dipole moment is 0. So for carbon dioxide we have seen a linear molecule, dipole moment is 0. BeF2, so here also linear molecule, dipole moment is 0. BF3 we have seen trigonal planar symmetry is there, therefore dipole moment is 0. So the correct option is D. So this is how we solve the questions if it is given. So we'll also see in the textbook, NCERT textbook, what is given. So important points, make a note of it. So you can see here when covalent bond is formed between two similar atoms, so like hydrogen, oxygen, Cl2, N2, F2. So as we have already seen, if same type of atoms are present, they are non-polar in nature. So the bond so formed is called as non-polar covalent bond. So what is polar covalent bond? So if it is formed between two different atoms, heteronuclear molecule like HF, the shared pair of electron between the two atoms get displaced more towards fluorine, that is more towards electronegative atom. As a result, you can see a polar covalent bond is formed. And here definition for dipole moment is given. It is defined as the product of magnitude of charge and the distance between the centers of positive and negative ion. So it is represented by mu. So here you can write dipole moment is equal to charge into distance of separation, and their unit is dBi. So 1 dBi is equal to 3.335 into 10 to the power of minus 30 coulomb meter. So remember this also, 1 dBi value 3.33 into 10 to the power of minus 30 coulomb meter, and it is a vector quantity because it depends on the direction. So here you can see HF. So you will be writing the arrow more towards the electronegative atom. So if you compare these two, fluorine is more electronegative. So you have to write arrow towards the fluorine atom like this. And then here you can see, in case of polyatomic molecule, so dipole moment will depend on this. So this is very important. They can ask on in polyatomic molecule, dipole depends on spatial arrangement of various bonds in the molecule. That is what I said, depends upon the geometry of the molecule. So the dipole moment of a molecule is the vector sum of the dipole moment of various bonds. Example, if you see water molecule, so here you can see water. So put this in the box and remember this. So you can see here lone pair they have not represented. So in water, two lone pair will be present. So here you can see oxygen is more electronegative compared to that of hydrogen. So arrow mark should be towards oxygen like this. So the resultant, so both are in the same direction. The resultant will be in this direction. Resultant dipole moment will be in this direction. So therefore dipole moment is not equal to 0. It is having some value. So how much it is? 1.85 dBi. So no need to remember the value. So just know that it is not equal to 0. And then BeF2. So I already told that there is no lone pair of electron and it is a linear molecule. So dipole moment you can represent arrow like this towards fluorine atom. So therefore they are in opposite direction. So they will cancel each other. Therefore dipole moment is equal to 0. Even in BF3 you can see. So the dipole moment which is exerted by these two, you see they are in this direction and in this direction. So if you add, the resultant will be in this direction. So this fluorine will be showing dipole moment in this direction. So these two will cancel. As a result, the dipole moment you will be getting it as 0 for BF3. And then they are comparing with ammonia and NF3. So this is very important. So this we have already, I have already shown how it shows the dipole moment. So here you can see nitrogen and hydrogen. Nitrogen is more electronegative. Therefore arrow will be towards nitrogen like this. And one lone pair of electron is present. Always arrow should be towards the lone pair of electron. So the net dipole moment will be in this direction. So you have to add the sum of all the dipole moment will be in this direction. Whereas in NF3, you can see for the fluorine atoms it is in this direction, and for lone pair of electron it is in this direction. So here it will cancel since they are in opposite direction. So these three will be resulting in this direction. So now some amount of dipole moment will be cancelled because this is in the opposite direction. Therefore their value is going to reduce. For ammonia 4.90, for NF3 it is 0.80. So don't remember the value, just remember for ammonia dipole moment is more when compared to that of NF3. So this is what in the first question we have seen. Just check the this one. Can you see here? BF3 has non-zero dipole moment. So BF3 will be planar molecule like this, F, F and F. So since symmetry is present, for BF3 the dipole moment is equal to 0. But here they have given non-zero, therefore this is wrong. And dipole moment of NF3 is greater than ammonia. So this is also wrong because ammonia has more dipole moment when compared to NF3. So this question came in 2024. So this is what is given, and finally they have given this table in the NCERT textbook. So that is, so here you can see H2 homonuclear, same kind of atom, if it is present, dipole moment will be 0. So carbon dioxide is a linear molecule, dipole moment is 0. So BF3 it has symmetry, therefore dipole moment is 0. CH4 is also tetrahedral, bond angle is same, dipole moment is 0. CCl4 also tetrahedral, dipole moment will be equal to 0. So only remember which is having dipole moment 0. So this much you have to know from the table. So this is what is given in the NCERT textbook. So students, I hope it is useful to you. Go through it once again, and if you have any doubt you can write in the comment section. Please share this video with your friends and also subscribe the channel. I'll meet you in the next video, students. Prepare well for your examination. All the very best.